The average IQ of an adult population is 100. A researcher believes that the average IQ of the adults is lower. A random sample of 5 adults are tested and scored 69, 79 up to 109. The calculated standard deviation is equal to 15.81. So they want us to test the claim. Test the claim that the IQ is lower. Test the claim that IQ is lower. That is lower than 100. Of course, here the average of the population, that is the new, is 100. Now, a researcher believes that the average IQ of the adults in this population is lower. So if the sample is this and we have calculated the standard deviation of this sample to be 15.81, then we can go ahead and test the claim. So that means here we are looking at a t-test or a t-statistic because n is less than 30 and the standard deviation is not known. Standard deviation, this is of the population. We can get that one of the sample, but that one of the population is not known. Here, this standard deviation is just simplifying life for us, but otherwise we can go ahead and first calculate it. You need to first determine, for example, the mean, and after determining the mean, you go ahead and get the standard deviation of this sample. If you are unable to do that, let me help you. That mean, sample mean, which is x bar, is equal to 69 plus 79 plus 89 plus 99 plus 109. Then I divide everything by 5. The average is equal to 89. Then for me to get the standard deviation of the sample, remember it is square root of xi minus x bar, everything squared, but when everything has been summed, then divide by n minus 1. So if I use that formula, I should be able to get the standard deviation. So the standard deviation will be, I get 69 minus 89 I square plus 79 minus 89 I square plus 89 minus 89 I square plus 99 minus 89, which is the mean, I square plus 109 minus 89 squared. Then I divide this by n minus, remember n is equal to 5. So n minus 1 will mean 5 minus 1, which is 4. So if I sum that, my s should be equal to 15.81 as calculated. So now we go ahead and test the claim. So we start with the null hypothesis. So the null hypothesis is saying the mean of the population, which is new, okay, must equal to 100. But the alternative hypothesis, remember this is H naught. The alternative hypothesis, which is H1, is equal to H1 is lower. So that means we are testing or we are carrying out a one tail test, which is a left tail test. So the alternative hypothesis is new less than 100. So since we are using a t-statistic, let us calculate our t-statistic. This is going to be x bar minus nu divided by s divided by n. And this is going to be the sample mean has been calculated as 89 minus 100 divided by s, which is the standard deviation of the sample, and this is 15.81 divided by root of n, which is 5. And if I calculate this very well, my t-statistic should be negative 1.56. So from there, I already know. I know the degrees of freedom. I know if I know the degrees of freedom, then that means I can be able to get the t-value. So I'm going to go to my table and look for the t critical value. So we are going to look at the number of degrees of freedom, and the number of degrees of freedom at 4. Okay, if we are looking at a one-tailed test, our p-value is always around 0.05, that is 5%, and we are going to zero this calculation to 5%. So the one-tailed test at the number of degrees of freedom equal to 4, our value is going to be 2.132. Okay, so what we are going to do, we are going to take 2.132. So we are going to draw our normal distribution curve. So the normal distribution curve is like this. So if we are carrying out a one-tailed test, this is alpha at 5%. The value is going to be, if the alpha at 5% is this side, the value is going to be, we said the 2.132. That is the Z critical value. Then Z critical value here is equal to negative 2.132.
Excuse me, sir.
Sorry, this is supposed to be a t value. Thank you for the correction. This is supposed to be a t critical value, and this is t critical value. So we said if it is at a 5% level of significance, it is going to be, if it is one-tailed test, this side it is going to be 5%, this other side is also going to be 5%, and then if the value that corresponded to 5% on our table was positive, then that means that value is on this other side. Then that means for us what we are interested in is the one which is negative, because we have a value of nu less than. So the less than, we are talking about the left tail test. And of course, you can also see that our t value is negative 1.56. So that means we are going to be testing values to this side of the negative. Remember, the 0 is at the center. So this is the rejection region. This is the rejection region. And where is my negative 2.13 is here. But the 1.56 must be before. So we can see that our 1.56, of course, which is negative, is outside the rejection region. So let us make some deductions here. We can see that the calculated t value is outside the rejection region. Decision, we fail to reject, because if it was within the rejection region, we would reject the null hypothesis. But if it is outside the rejection region, we fail to reject the null hypothesis. That is H naught. So what does that mean? The conclusion that we are taking is that there is no sufficient evidence. There is no sufficient evidence to show that the I2 is less than what? Less than 100. So when you look at this problem, it wanted us to test the claim. So, and the claim is the hypothesis test is showing us that we cannot reject the null hypothesis. And the null hypothesis was saying that the mean is about what? The mean is about 100. So we shall say that actually the mean IQ of the people who are adults from this area, that IQ is around 100. It is not less than 100.